Okay, let's graph this system of equations, and they're in very unusual form. The first one is in slope, -3, slope, y-intercept of a +5 form. So I'm going to go up to the +5, and then I'm going to graph the slope. I'm going to put some ordered pairs in. Remember, this is a -3 over a +1 when there's nothing there. That's what that means. So I'm going to go down 3 and to the right 1, down 3 to the right 1, down 3 to the right 1. I could have gone up 3 and to the left 1 for that negative slope. So up 3 and left 1, up 3 and left 1. And I'm going to connect the dots. So there's the graph of that line. What's interesting about these two is when I get this one in slope-intercept form by subtracting 3x from both sides of the equation, this one turns out to be y equals a -3x also. But it had a -2 on the right side of the equation, so its y-intercept is a -2 right here. But there is no way when two lines have the same slope, absolutely no way when they have the same slope. So down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. There is no way for those lines to intersect with the same slope. And we say that this system has no solutions because they are parallel lines. Again, we could graph this on our graphing calculator. It would say the same thing. I'm going to demonstrate that in a minute. But again, no solutions, and a system that has no solutions is often called inconsistent. No answers. The next problem, and actually I will stick this on the graphing calculator really quickly. So our first equation was y equals a -3x plus 5. And then our next one was y equals a -3x, I think that was a -2. And I can hit the graph key and see the first line come down with that negative slope, -3. And here's the next one, just like we did on the paper. Don't forget from previous Tech Math class, if you wanted to set your table to start at some number and automatically give you values for x and y, don't forget that you can have tables of data to graph a line as well. So in the first equation, when x is 0, y is 5. When x is 1, y is 2. When x is 2, y is a -1. In the second equation, when x is 0, y is a -2. These are both the y-intercepts, 0, 5 and 0, -2. So don't forget that. The next question, and I'm going to see if I can get through this whole segment here now. The next question, they end up being the same two lines. So I'm going to give myself some space to solve these and get them in terms of y. So I'm going to add 2x here and add 2x here. So I'll have 3y equals, I'm going to put the 2x first and then the 6, and then I'm going to divide both sides by 3. So this equation turns out to be y equals 2/3 x plus 2. 6 divided by 3 is 2. I'm going to get this next equation. I'm going to get y alone, so I'm going to subtract 8x from both sides. On the left, I'll have a -12y equals, I'll put the -8x first and then the -24. And then I'm going to divide both sides by the -12 to get y alone. And I'll have y equals, a negative divided by a negative is positive. 8 divided by 12 is reduced to 2 over 3. Here, a negative divided by a negative is a positive 2, and lo and behold, look at those two lines. They are the same line. They sure didn't look it to begin with. Remember, this is what we started with right here. But when we got them reduced down to slope-intercept form, I'm going to see if I can get graph paper to show up here. They were both equal to y equals 2/3 x plus 2. So plus 2 is the y-intercept. And I'll go up 2 and to the right 3. Up 2 and to the right 3. Up 2 and to the right 3. So I'd graph the first line And then I'd graph the second line right over top of it. So they are the same line. This is a consistent system. The other one was inconsistent. This is consistent because it has many solutions, is what you would tell me. It's because they are exact same line. Some people would say that the solution is any x and y value that fit in either of the original equations. So any x and y value that fits in 3y minus 2x equals 6 would be a solution. To tell me that many solutions is the solution, that's good enough. All right, I'm going to skip the next problem, and if you'd like, work it on your own, but I will not be dealing with something with so many fractions, and I'm afraid it would just take quite a bit of time. We could do that in class if you'd like. The next story problem says two angles are supplementary. And then it says one of the angles is 3 degrees less than twice the other. So if the other angle is x, then it says one of the angles is 3 degrees less than twice the other, less 3 degrees. But it also says they're supplementary, which means they add to be 180 degrees. So I'm going to actually should have written this as in terms of x and y. So I'm going to come back and write this differently in a minute. So I want to have two letters. So if the sum of the angles is 180 degrees, I'm going to write x plus y equals 180 degrees. And then I'm going to say that x is equivalent to twice y, the other angle, minus 3. So I wish to have used a y here instead. One of the angles is equivalent to twice the other minus 3. So this is a better way to save that. So let's see, if I put this in slope-intercept form, I'm going to add 3 to both sides. So I'll have x plus 3 equals 2y. And then I'm going to divide both sides by 2. And I'll have y equals 1/2 x plus 3/2. I think I did that okay. Here, I'm going to subtract x from both sides, and I'll have y equals a negative 1x plus 180. Can you imagine me trying to put a y-intercept of 180 on paper with the slope only being a negative 1 over a positive 1? Yikes. Instead, what I'm going to do is I'm going to go to my graphing calculator and I'm going to hit the y equals key and I'm going to clear these other equations out and I'm going to put in the negative x plus 180. And then I'm also going to put in the other equation, which was 1/2 x plus 3/2. 1/2 x plus 3/2. Now, my window is going to be no good because the y-intercept is a positive 180. So I know that this has got to go, the y-maximum's got to go at least up to 200. That's one thing I know. I'm kind of wondering, since the slope is negative for this one and the y-intercept is 180, so it's way up here and it's a negatively sloping line, I think I better go out in the x direction on my graphing calculator out to 200 as well, would be my guess. So I've had to open my window. Let's see if I'm okay. You know, I can change my scale if I want. I could go in increments of 10. So that I won't change this one, so you could see that the y-axis is going to be a black line because it put tick marks everywhere on the y-axis, but on the x-axis it put a tick mark every 10 units. So I knew I had to open it up to 180 or about 200, and I knew this sloping line was very slight, so I had to go way out here in the x direction to see the intersection point of these two. So now I'm going to go second, calc. I must not have hit the trace key. Let's go second. I'm going to hit pause. Okay, I'm back. So it accepted the second calc and it's sitting on equation number 1. So I'm going to hit enter. And now, Boy, I actually think it didn't work. So I'm going to go second and then the trace key again. And I didn't tell it yet that I wanted to do number 5, which was find the intersection. So it says where's the first curve? So here's enter. It says where's the second curve? Here's enter. It says guess. Here's enter again. So it's enter, enter, enter. The two angles are 119 degrees and 61 degrees. So let's go back and put that x was, I think it was 119, and then it must have been the other one was 61 because they're supplementary. I hope I have that right. I guess I'm going to go peek. 119 and 61. Yep. And so the intersection of those 119 and 61 degrees. And then let's just check. Let's see if 2 times 61 minus 3 would give me the 119, and 2 times 161 is 122, and you subtract 3 and you do get 119. And then do these angles add up to 180 degrees? You bet they do. I think I might come back and try to do the next story problem, but you know, I may leave you on your own for that one. We'll see. And if so, I'm going to change those R1s and R2s to X's and Y's.